3I Atlas, this strange interstellar visitor, is not just a comet, not just a frozen rock from another star system. 3I Atlas had been struck head-on by the Sun's own plasma and lost its tail. On September 25th, the Sun erupted in a way nobody alive had ever seen before. For days, its surface had been boiling with dark sunspots and looping arcs of plasma like warning tremors before an earthquake. But at 3:47 UTC, the tension finally snapped. A blinding flash rolled across the Sun's disk, and a colossal loop of superheated gas rose tens of thousands of miles high, then snapped loose and hurled itself into space, which is known as a CME, or coronal mass ejection. It wasn't just light and heat. It was billions of tons of electrified plasma threaded with magnetic fields moving at over 1.6 million PL. Scientists watching the real-time feed saw their gauges spike far beyond the red zone. Instruments calculated the blast at about 1.2 trillion megatons of kinetic energy, an amount so large it's hard to comprehend. Think of every nuclear bomb humanity has ever built, then multiply that by 20 million. Or imagine the energy released by the asteroid impact that killed the dinosaurs. Then imagine 20 of those detonating at once, all aimed straight at one small point in space. NASA's space weather models showed the shockwave rolling through the inner solar system like a flaming hurricane. Its aim was terrifyingly precise, directly at 3I Atlas, the enormous green interstellar object streaking toward a near pass with Mars. For months, this emerald stranger had been unsettling scientists. It was already far heavier than any known comet, more than 33 billion tons, with a core over 5 kilometers across. Its green glow came from gases and metals that don't belong in a normal comet's tail. Diatomic carbon, nickel, cobalt, compounds more like industrial exhaust and frozen cosmic ice. And now, at the moment of its closest approach to the Sun, it would take a hit from the most powerful solar storm ever measured. In observatories from Hawaii to Chile to the Canary Islands, astronomers gathered in control rooms and stared at their screens in dark anticipation. Comets have been known to lose their tails or even disintegrate under much smaller CMEs. This one was orders of magnitude larger, a hammer blow of star-forged plasma capable of ripping apart a gas giant's magnetosphere, so strong it could warp Earth's magnetic field into a knot and snap it. When the CME finally struck, the spectacle was immediate and shocking. The green tail of 3I Atlas snapped like a whip, a luminous streamer tearing free and vanishing into the solar wind in less than a minute. Its bright coma, the glowing halo of gas around its nucleus, collapsed inward as if someone had pulled the plug. Spectrographs from Chile's Rubin Observatory showed its light curve plunging. Doppler readings from NASA's Deep Space Network registered a breathtaking deceleration from a blistering 37,000 miles an hour down to just 5,000, as though an invisible hand had slammed the brakes. For the first time since its discovery, the mighty green visitor looked like a dark, inert lump, drifting helplessly toward the Sun. In observatories from Chile to Hawaii, researchers erupted in cheers. Months of sleepless nights and speculative panic seemed to dissolve in an instant. The anonymous mass and green glow, the Mars flyby, the whispered worries of an alien mothership, all of it neutralized by our star. It felt like the end of a cosmic horror movie where the monster finally burns up in the last reel. But then the impossible happened. Exactly 2 hours and 7 minutes after the CME strike, a faint flicker appeared at the heart of the darkened mass. It pulsed once, twice, then flared violently, a beacon bright enough to saturate detectors. Sensors at the European Space Agency's solar orbiter picked up a surge of emissions. The same nickel, cobalt and diatomic carbon signature as before, but stronger, richer, unmistakable. In a single breathtaking moment, a new tail shot out from the nucleus, perfectly symmetrical, emerald green, and even more brilliant than the original. Then the speed readings ticked upward, 10,000 muffs, 50,000, 100,000, until the object was once again blasting along at 37,000 dPusme on its path toward Mars, as if nothing had happened at all. What people were seeing defied physics. A natural comet can't be hit by a plasma wave powerful enough to melt planets, and then casually regenerate its tail and speed. Even the strongest magnetic field of any planet in our solar system would have been torn apart in that blast. Yet here was 3I Atlas, its emerald tail blazing, moving at full speed as if it had fed on the sun's fury instead of being destroyed by it. Scientists were left staring at their screens in stunned silence. No natural comet could regrow a tail and regain its exact velocity within minutes, not after being hit by a plasma wave powerful enough to boil oceans. Even the most powerful planet in our solar system would have been scorched under that assault, and yet here was 3I Atlas, emerald tail blazing and moving at full speed. Shrugging off physics as though physics did not apply, Low explained it in simple terms. For weeks before September 25th, instruments on NASA's Solar Dynamics Observatory had shown odd patterns on the sun's surface, tiny magnetic quakes lining up with the side of the sun facing 3I Atlas. It looked, he said, like something was poking or tickling the sun's magnetic field until it snapped. To him, the timing of the CME wasn't a coincidence. It was as if 3I Atlas had known exactly when the eruption would happen, or had caused it. He compared it to a ship at sea raising a sail to catch a gust of wind. Only here, the wind was a billion-ton blast of plasma and magnetic fields, powerful enough to strip the air off a planet. Instead of dying under that storm, 3I Atlas may have opened its sails and absorbed it. We've never seen anything like it, Low said. If this is a comet, it's one with a powerful system beyond our comprehension. Low's working idea was that the object isn't a snowball of ice and dust at all, but a gigantic machine wrapped in a kind of invisible shield. Imagine a huge magnetic bubble or super-strong electromagnetic net around it. Such a bubble could bend the sun's plasma around the craft, soak up the energy, and funnel some of it inside. In this way, the CME, which should have been fatal, would instead become a refueling event. He even speculated about the kind of engine that could do this. One possibility, he said, was a type of fusion engine helped by an unknown catalyst from dark matter. In normal fusion, like the reactions inside our sun, you need incredible heat and pressure. But if you could use something exotic to make fusion easier, you could run a power plant in space using the sun's own plasma as fuel. It is speculative physics on Earth, but a logical path for a civilization millions of years ahead. In such a system, a coronal mass ejection would be a free tank of fuel, not a death sentence. Low also highlighted hard evidence to back this up by a reanalysis of Hubble and ground-based observations. Polarization measurements hinted at an extremely smooth surface under the coma, unlike the jagged rock or ice surfaces of known comets. Radar returns from Goldstone showed a faint lattice pattern inconsistent with a natural body. The object's mass distribution, a dense outer ring and hollow interior, matched what you'd expect from a gigantic shell rather than a solid core. If you put all of this together, the simplest explanation is that we're not looking at a natural object at all. We're looking at a machine that's using our star as an energy source. The strange pulsing brightness could be its fusion drive throttling in response to solar energy, and its apparent swelling mass might be the result of harvesting planetary material, a ship refueling on the fly. That would explain why it seemed to grow as it approached the